Hello, I'm Jordan Adamson from Team 18, and this is our final presentation for our instrument designs to be used by Maroon and Gold 4 on their up-and-coming tour. I've designed for you a thumb piano constructed from a wooden cigar box, utilizes wooden chopsticks cut to various lengths, supported cantilevered between two wooden supports. Key features of this design are its compact nature, its ease of play by the musician, excellent visual appeal, sure to please both the musician and the fans, as well as bearing no weight on the specific material constraints of the project. I'll now discuss the underlying physics behind the operation of this instrument. The musician plucks the bar corresponding to the note that they desire to play. This produces a vibration in the bar, which displaces the surrounding air. That displaced air propagates a sound wave to be heard by the listener. On slide 2, you can see the various lengths that I've cut these bars to corresponding to the frequencies for the required notes in the high voice portion of Alma Mater. You will also see the equation that I utilized to determine those lengths. Changes that I made throughout the design process include the use of wooden chopsticks by initial brass bars that I anticipated using. Um, the wooden chopsticks both cut down on cost and provided better sound quality. I also decided to use a hollow box with a hole cut in it by a solid wooden support, which also added to the improved sound propagation as well as cut down cost. Uh, the final budget can be seen on slide 3. All materials included, as well as a fresh coat of stain for visual appeal. The grand total came to $5.86, well below the $15 limit for the project. Challenges that I faced throughout the project were difficulty drilling straight and consistent holes in the support. I used a drill guide to help ensure trueness of those holes, as well as difficulty with the sound quality of the previously mentioned brass bars, which I replaced with these wooden chopsticks. Improvements that I would make in the future would be possible testing of other materials to get even better sound quality out of this instrument. I will now give you a short demonstration of me playing my thumb piano. That concludes my portion of this presentation. I'll now hand you off to Lee Peterson, who's very excited to show you about his clarinet design. Thank you for your time.
Hello everyone, I'm Lee Peterson and this is Team 18's PVC clarinet, complete with Sparky's pitchfork and ASU colors. So how does this work? At the top here we have a B-flat clarinet, mouthpiece, and a reed. When the player blows air over the reed, it will vibrate back and forth, which creates a sound that reverberates down the tube. And the sound will go through the first hole that is open. So when you cover holes, it will play a different sound for every hole down the length of the tube. And on this slide, so you can see we have the equation I use to calculate the length at which each frequency can be played with on the PVC pipe, along with a chart of the notes and their corresponding lengths on the pipe. In regards to materials used to build a PVC clarinet, I added several materials, namely the clarinet mouthpiece, the rubber patch, the rubber band to secure the reed, duct tape, piston seal. Both of those are to help build this little bridge for the mouthpiece. And the final cost for this PVC clarinet was $5.82, which is just slightly under $2 more than my initial design's projected cost. As you can imagine, my final instrument is quite a bit different than my initial design. The biggest difference with this instrument is that the B-flat clarinet mouthpiece is used instead of a slanted cut with the tenor saxophone reed. I went with this clarinet mouthpiece mainly for safety reasons. This paint I used for the aesthetics on the instrument is a known carcinogen in California. So I figured having a clarinet mouthpiece would allow the player to operate the instrument safely, and it also creates a very nice sounds comparable to an actual B-flat clarinet. Aside from that, there are no other design changes except for the aesthetics. I did not have that in my drawings. And in terms of improvements for this instrument, what I'd like to do, or for the final design, would be to make this 3D printed. The body of it could stay the same, but I'd like to make this little end piece that connects to the barrel and the clarinet, or right here, what this little joint is for. I like to make this threaded and fit inside of the PVC tube. I'd also like to get an instrument or tool to thread the inside of this, so that you can just screw the mouthpiece on. In addition to that, one other improvement I'd like to make is to add a little kind of like thumb rest, kind of like with my B flat clarinet here. Just add something like this so that it can kind of rest on its side upwards, so that if you don't want to play it and you don't have a stand, you could just set it horizontally and it would raise itself a bit so that the reed does not touch the ground. Some of the main features of this instrument are the rubber patch on the mouthpiece to help protect the mouthpiece from your teeth. It will eventually wear away, kind of like with the B-flat clarinet or any other instrument like a saxophone that has a mouthpiece like this. It also has a rubber band for easy adjustment of the reed, which is critical and able to play sound correctly and to produce a nice sounding sound. This little center section is also kind of modular, so you could take it apart for cleaning it. And it also features the ASU color. Here's a quick demonstration of the PVC clarinet in action. Thank you for your attention. We hope you enjoyed this demonstration of our prototypes, and we look forward to working with you further.